Hello and welcome to this lesson for A-Level Physics on the OCR specification looking at Module 3, Forces and Motion. We're looking at the subchapter of Forces in Action and the topic of density. So in today's lesson we're going to be looking at how to calculate the value of density. So if we've been successful and we've learned in today's lesson, we should be able to know the definition of density, calculate the value of densities, and know the value of density can be estimated from the volume of a material. So we're going to be looking at the following part of the OCR A-Level Physics specification. 3.2.4 Density and Pressure, looking at this subtopic of A, density. So the density is the amount of matter in the substance in a certain volume. So density is how much mass of a material there is in a certain volume. So you could think of this as a measure of the number of particles in a certain volume, or it's a measure of the space between the particles in a certain volume. Now this tells us that density could be thought of as a measure of how spread out the particles are in a certain volume for a substance. So if an object is very dense, it means that it has lots of particles per unit volume. So if the object is very dense, there are small gaps on average between the particles in the substance. Now if an object is not very dense, then it has very few particles per unit volume. So what that means is if an object is not dense, there are large gaps on average between the particles in the substance. So we can think of density as the mass of a substance in a unit volume. So therefore, we can calculate density with the following equation. Density is equal to mass divided by volume. Now, if we wanted to use our standard units, we would say that density is measured in kilograms per meter cubed, with the mass in kilograms and the volume in meters cubed. So therefore, you could also think of density as the mass of 1 cubic meter of a substance. So for example, gold has a density of 19,300 kilograms per meter cubed. So it means that 1 meter cubed of gold has a mass of 19,300 kilograms. Now, the units of density tend to be kilograms per meter cubed, but it doesn't always have to be that. The unit of density can always be written as the unit of the mass divided by the unit of the volume. So if the mass was in grams and the volume is in centimeters cubed, the unit of density will be grams per centimeter cubed. Now the density of an object is only dependent on what it is made from. So the density of a material does not vary with either size or shape. So as we mentioned before, an object is very dense if it has lots of particles per unit volume, and an object is not very dense is if it has few particles per unit volume. So we can now relate this to the particle model of matter. So this shows us the idea that solids have a higher density than liquids, and liquids have a higher density than gases since they have more particles per unit volume. Or you could think of it as that solids have a higher density than liquids, and liquids have a higher density than gas since there's greater space between the particles per unit volume. But fundamentally, the solids are high density, the gases are low density, and they're an increase in density from gases to solids. Now technically, a vacuum has a density of 0 kilograms per meter cubed, as there are no particles in the volume at all on average. Now, density is a very important property in the real world because density can determine if an object floats or sinks. So if an object has a higher density than the fluid it is in, it will sink. If an object has a lower density than the fluid it is in, it will float. Now, water has a density of 1 gram per centimeter cubed. This means that can be used to determine if a material will sink or float in water. So you could think of 1 gram per centimeter cubed as that 1 centimeter cubed of water has a mass of 1 gram. So let's have a look at how to calculate density. So if we've got a mass of 6 grams in a volume of 2 centimeter cubed, what is the density of the substance? So the density is the mass divided by the volume. So it's 6 grams over 2 centimeter cubed. So therefore the density is 3 grams per centimeter cubed. But what if you're not given the volume of the object? Now, if the shape is regular or symmetrical, we can find its volume by using one of the equations you use in mathematics. So for example, the volume of a sphere is 4 pi r cubed, where r is the radius of the object. The volume of a cube is L cubed, where L is the length of the object, and the volume of a cylinder is pi r squared times by h, because h is the height of the object. So let's have a look at a different question now. If we have a mass of 20 grams in a sphere with a radius of 4 centimeter cubed, what is the density of the substance? So you can say density is mass over volume. Then you can work out the volume of the object with the mathematical equation, 4 over 3 pi r cubed. Pop in the values. You can then say density is the mass, 20 grams, over the volume, 268 centimeters cubed. So the density is 0.075 grams per centimeters cubed. Now, densities can be very useful to identify materials in the real world. If you have an unknown solid substance in a material or an object, you can use the value of density to identify the material. So every solid material has the same density regardless of object dimensions. So if you can calculate the density of a solid material, you can work out what the material is. So here, for example, you can see some different examples of densities of different solid materials. So for example, aluminium always has a density of 2.64 grams per centimeter cubed regardless of the object shape that it has. So if you can work out the density of a material, you can identify what the material is. Now you must be able to work out the density for objects which are either regular or symmetrical, or irregular or non-symmetrical. Now for both types of objects, the mass is measured with a balance. The mass of any object is always measured with a balance. Then you can work out the volume, but for a symmetrical or regular object with a mathematical equation. So with the regular shape, consider something like a 3D symmetrical shape like a cube, but it can be carried out for any regular 3D shape. You can calculate the volume by measuring the different dimensions, so in this case the lengths of the cube. So you can measure length 1 here, then length 2, then length 3. We know that because it's a cube, the volume is the length 1 times by length 2 times by length 3. Then we have our mass, we've worked out our volume, so density is mass over volume. We can work out the density of this regular shaped material. But what about an irregular shaped object? Once again, we measure the mass with a balance. But to find the volume of an irregular shaped object, we must use a method called water displacement. So we put the object in a measured amount of water and measure how much the water rises. The difference is the volume of the object. We can then measure the mass using the balance. And then from this, we can calculate the density of the object. So consider a beaker of water. You can place the measured object in this beaker of water. The object will displace its own volume of water in the beaker. So therefore it will cause the water level of the beaker to rise, and the difference it rises is the volume of the object. So how much this water level rises can be considered to be the volume of the fully submerged object. So the change in the water level gives you the volume of the object. You observe this effect when you get into a bath or you put dishes into a sink full of water. So for example, if we start off with a beaker of 300 mils of water, we fully submerge an object into the beaker and it rises to 500 mils. Well, therefore the volume of the object is 200 mils, because 500 minus 300 equals 200 mils. If we then know the mass of the object, so for example we could say the mass of this object measured with the balance was 200 grams. We would say density is mass over volume. 200 grams over 200 centimeter cubed is 1 gram per centimeter cubed. Now, alloys must have their densities calculated slightly differently. That's because alloys are a mixture of two or more metals. Now, whilst the volume of a substance is not affected by the mixture of the different particle types, the mass of the object is affected. So it's a very important idea. So we must consider the density of different types of metals. So for example, for an alloy of volume V with two metals made up in the alloy, A and B, we can consider the volume of metal A to be volume A, and the mass of A to be the density of A times by the volume of A. And we consider the volume of metal B to be VB, and the mass of B to be the density of B times by the volume of B. This is coming from the equation that mass equals density times by volume. We can then use this to work out the density of the alloy, because density is mass over volume. So we can say V is going to be the total volume of the alloy. Now we can say that the total mass over the total volume equals the total density of the alloy, which you can calculate the total mass by doing the density of one of the metals times by the volume of one of the metals, plus the density of one of the metals times by the volume of the other metal. So if you look at this particular equation, the term rho AVA plus rho BVB is the total mass of the two metals in the alloy. So let's have a look at an example of how this works. Brass is an alloy which consists of 3.3 times 10 to the minus 5 meters cubed of copper and 1.7 times 10 to the minus 5 meters cubed of zinc. What is the density of brass when the density of copper is 8,900 kilograms per meter cubed and the density of zinc is 7,100 kilograms per meter cubed? So you work out the mass of the copper by doing the density of the copper times by the volume of the copper. So you work it out to be 0.294 kilograms. You work out the mass of the zinc by doing the density of the zinc times by the volume of the zinc, so it's 0.121 kilograms. The total mass is the mass of the copper plus the mass of the zinc, so it's 0.415 kilograms. The total volume is the total volume of the copper and the zinc, so it's 5 times 10 to the minus 5 meters cubed. So therefore the density is the total mass over the total volume, so it's 8,300 kilograms per meter cubed. And that's how you work out the density of an alloy. So that brings us to the end of this particular lesson. So in this lesson, we've looked at the concept of density and how to work it out with the equation rho equals m over v. So if we've been successful and we've learnt in today's lesson, we should be able to know the definition of the term density, calculate values of density, and know the value of density can be estimated from the volume of a material. So thank you for watching this particular lesson for A-Level Physics on the OCR specification, which was Module 3, Forces in Motion, in the subchapter Forces in Action on the topic of density. Thank you very much and have a lovely day.